So now the third type of test that we want to run is an ANOVA. When do we know that we need to run an ANOVA? Anytime that we have 3 or more groups is when we want to run the ANOVA test. Okay, technically you can run it with 2 groups, but for the purposes of this course, you only need to worry about doing it for 3 groups or more groups. Like we can have more products here, we can have product D, product E, product F, but as long as it's 3 or more, then we are going to run an ANOVA. Okay, so in this case, in this example, we have 3 product categories that the company is manufacturing and selling to various markets. The numbers that are being shown here, and there's not a lot of samples either. So for ANOVA, it really doesn't matter how much samples you have, but what the numbers are showing here are units sold. And we want to know whether there's a significant difference in the units sold in each of these 3 product categories. Perhaps the company is interested to see if product B outperforms, for example, product C, or one of these products is doing better and they warrant further investigation, for example. So they just want to compare these 3 groups to each other. We have the alpha again, and to do this question, to answer whether or not there is a significant difference, we need to do an ANOVA. So the way that we do this is we go into and do our hypothesis test. We set up the null and alternative hypothesis. The null hypothesis is going to be the status quo or the no change hypothesis, which is the null hypothesis is there is no difference between these 3 different product lines. So alternatively, the alternative hypothesis is that there is a significant difference between these 3 product lines. So let's go ahead and set up the ANOVA. We want to go back up to the data analysis tab. It's all the way at the top, ANOVA single factor, right at the top here. I'm going to press OK. Before we do, notice that we didn't need to put any dummy column in here. That's because ANOVA doesn't need to have a dummy column with zeros here. So we don't need to do that for this one. So we click OK, this dialog box pops up. So for input, we want to put all the data that we have, all the data. All the data is being grouped by the columns. So product A, B, and C, all of these numbers refer to product A, all these numbers refer to product B, all these numbers are product C. So all of our data is being grouped by columns. So we want to make sure that's checked. The labels are in the first row. This is the first row. So we know that that's all gonna be labeled that way. I accidentally changed this, so let me just change that back. Perfect, yeah, so that's correct. Labels in first row. Alpha is gonna be 0.05, as that's already given to us as the significance value. Output range, let's put that here, and let's press OK. Once we run the ANOVA, we get a bunch of data. We essentially get 2 tables. We get a table here at the top, which gives us a quick summary of the details of the analysis that we've done for the 3 different product lines. So for the 3 different products, we have a count, we have a sum of the units sold, we get the average units sold, as well as the variance. But for our hypothesis testing, we're really looking at values in the second table. Specifically, we want to look between the groups, and we want to look at the p-value between all 3 of these groups. The p-value is 0.19557. The p-value at 0.195 is greater than 0.05, which is the alpha value. So when p-value from the ANOVA is greater than alpha, we failed to reject the null hypothesis, which means that this is most likely valid. So then we state the conclusion that in conclusion, using the ANOVA, we failed to show that there is a significant difference between the 3 product lines. So the null hypothesis is valid.